this minus of this is nothing but this equation. So in y terms we can express, because y is this thing, and then yi into yl, zl, because that's y. And here also this whole thing can be yi and 1 minus yl, because z is there, I is equal to l. This ZL again we got from, we have expanded whole sigma, and for that ZL only it is able to derivative we can find. For others it is 0, because if there is sigma notation is there, in that time we have cases. And again in this like normally for softmax or activation functions, we have this type of cases like I is equal to L, I is not equal to L, because at one spot only we'll get high probability, others is 0. And derivative of with respect to I is equal to L we are finding means at that point only derivative is there, and if it is e power x means e power x we will get an output, for others we will not get. So that's why we are getting something like this. So ZL, here ZL, yi, ZL, so ZL means there means yi, yl, and here ZL is there, that's why it's yl, and others times it's yi only, because we have taken yi, a derivative of yi with respect to derivative of z when I is equal to L and when I is not equal to L, two cases. So summarize, this is the results, and now we need to find derivative of loss with respect to z. Loss equation is this, and if we want to find y for all those classes we need to go as we have shown earlier, like binary cross entropy loss, yeah, this thing, this whole sigma, that can be shown something like this only. Now derivative of loss with respect to ZL means yk come over here and it will go inside, and yk derivative of yk, and then we can just in a chain rule we can involve yk by ZL, because inside yk we have ZL, so we need to have chain rule. And if you will derive that, we need to find this thing, and derivative of log of yk with respect to yk is nothing but 1 by yk, so capital yk by small yk, and this thing softmax gradient yk by zk, this we have found it over here, although while summarized form we have shown. And that we can just express if I is equal to L, k is equal to L, we can just keep yl, and other times this thing I is equal to L we can just keep that, and it's plus, and again minus is there, that's why minus. For k is not equal to L it will be minus is over here itself, so again minus will come yk yl, I is equal to L, right? So yk yl, and I is equal to, and here it will be yk yl, here it will be yk yl. So I is equal to k for here, because we are this thing, and here it was counter variable is I, here counter variable is k, other times it will be L, that means I is equal to L we will notate over here, and here we have to show k is equal to L, k not equal to L, here I is equal to L, I not equal to L. So based on counter variables we need to show, and then we can just simplify and we can turn that down to simple equation, something like this. So here what happens, these two will be cancelled out, we will get this, and here these two will cancel out, we will get this, and now we can take this yk yl, we can simplify this, y minus yk plus yk yl plus this thing, and now we can just keep yl common, and this yk comes over here, and this sigma yk comes here, capital yk comes over here, and minus of this thing comes over here. Now what happens, here what happens is this thing, whole thing is 1, because yk is there, right? And sigma of k not equal to L, and that is yk, and this yk we have got from here, yk yl, yeah, this thing, and this yk is actually is nothing but actual value, and it's an actual result. right? And if we are, this is the actual value what we are, and for that y, for actual value only we are giving higher probability. So that is nothing but k is equal to L, here k, here I, right? Counter variable. So k is equal to L yk, it is that. So if you sum that, sum of probabilities of the y should be 1, right? If we are high probability for this is 0.2, for other summation it should be 0. No, for higher probability if it is 0. For higher probability if it is 0.8, other summation should be 0.2, right? Some of those probabilities should be 1. Some of the all observations probability should be 1. That's a basic rule of probability. So this is k not equal to L and k is equal to L. The sum probability sum will be 1. So YL into 1 minus YK. So YL minus YK. That's how we are getting the answer. And here ZL, with respect to ZL, we can just turn this k is equal to turn this to L. So with respect to ZL, we will get YL. So here as k is equal to L or with respect to ZL. So here as k is equal to L or with respect to ZL we are doing. So we can just turn k is equal to L and the final equation will be YL minus YK or YL minus YL. So YL minus small YL minus, so the final equation will be small YL minus capital YK or small YL minus capital YL for k is equal to L or with respect to ZL we are doing.